हेलो एवरीबॉडी। सो आज के वीडियो में हम लोग कोरियोलिस फोर्स के बारे में समझेंगे। नाउ दिस इज़ रियली सिग्निफिकेंट क्योंकि इसका इम्पैक्ट वी कैन सी ऑन लॉट ऑफ ग्लोबल जोग्राफिकल फिनोमिनास, जैसे कि ओशन करेंट्स का मूवमेंट हो गया, ग्लोबल एटमॉस्फेरिक विंड्स का फॉर्मेशन एंड मूवमेंट हो गया, एंड साइक्लोन का फॉर्मेशन हो गया। सो लेट अस नाउ अंडरस्टैंड व्हाट एग्जैक्टली इज कोरियोलिस फोर्स। सबसे पहले ये समझते हैं, इट इज़ नॉट अ फोर्स, नॉट अ फोर्स इन दी न्यूटोनियन सेंस, जैसे कि आपका ग्रेविटी हो गया या इलेक्ट्रोमैग्नेटिक फोर्स हो गया। इफ़ इट इज़ नॉट अ फोर्स देन व्हाट इट इज़ एन इफेक्ट ऑफ अ रोटेटिंग फ्रेम ऑफ रेफरेंस। सो एनी ऑब्जेक्ट that is moving in a rotating frame, that object experiences a effect called Coriolis effect. In our case, what is that rotating frame? That rotating frame is Earth. So due to rotation of Earth, objects moving on Earth are either deflected towards their right or deflected towards their left. In the northern hemisphere of Earth, the deflection is towards the right of the direction of motion, and in the southern hemisphere of Earth, the deflection is towards the left of direction of motion. This deflection is called Coriolis effect. Let us now understand this through an analogy. For that, we have considered a rotating frame which is a merry-go-round. Now let us assume that the merry-go-round is rotating in the anti-clockwise direction. The person sitting on the frame is trying to throw a ball to person B. But because of the anti-clockwise rotation of the frame, the person B will shift slightly to his left. Similarly, the person C will also shift slightly to her left. Now the ball which was going to person B will move directly to person C. This apparent deflection is because of the rotating frame. Now if we consider an actual example, we can see here is the movement of global atmospheric winds. We can also see that the winds blowing to the south of the equator are being deflected towards their left, and the winds blowing towards north of the equator are being deflected towards their right. This deflection is basically called the Coriolis effect. Let us now understand the cause or the science behind the Coriolis effect. For that, we have taken a rotating disc with a time period of rotation equal to 5 seconds. Now assume that there are 2 points, point A and point B, on the same rotating disc. Both these points will have the same time period of rotation of 5 seconds. This is because the angular speed of rotation of all the points on a rotating surface is always the same, but the linear speed of rotation varies. So let us now understand what is linear speed of rotation, because that is very important for our understanding of Coriolis effect. Here the same disk is shown with this being the axis of rotation around which the disk is rotating in the anti-clockwise direction. Now let's say the disk rotates from this point to this point, so the angle that the disk will cover is this much. Now all the points on the disk will rotate by the same amount of angle, right? So by that logic, if the disk rotates entire 360 degrees, all the points on the disk will rotate by 360 degrees, right? So if we take this bigger circle or this circle or this circle, the angle covered by all the circles in one complete rotation will be 360 degrees. But the time period of rotation is already 5 seconds. If the angle covered is same and the time period is also the same, so angular speed must be same for all the points on the disk, right? Because the angular speed is given by 2 pi upon the time taken, where 2 pi is equal to 360 degrees. Now for linear speed of rotation, let us take 3 points, point A, point B and point D. In one complete rotation, the point D will cover this bigger circle, point B will cover this circle, point A will cover this circle. If we open all the circles, this will be the distance covered by point D. This will be the distance covered by point B and this will be the distance covered by point A. And the time taken by all the points is same 5 seconds. We know that speed is equal to distance upon time. So we can say that the speed of point D is greater compared to point B is greater compared to point A. And this is basically the linear speed of rotation, right? So we can say that as we move away from the center, the linear speed of rotation increases. Now coming back to the original disk. Here with the same logic we can say that at the center, since the circle covered or the distance covered is the least, hence the linear speed of rotation will be minimum, and as we move away from the center, the linear speed of rotation will increase gradually with the edge having the maximum linear speed of rotation, right? So linear speed of rotation is minimum or 0 at the center, gradually increases away from the center and is maximum at the edge. Now consider this disk as the top view of Earth. In that case, the center will be the pole and the edge will be the equator, right? Now applying the previous logic, we can say that the linear speed of rotation of the pole will be minimum, and as we move away from the pole, the linear speed of rotation will increase gradually and will be maximum at the edge of the disk or at the equator, which is the biggest circle of the Earth, right? We can further understand the same by this 3D image of the Earth, where we can see that this is the equator at the center of the Earth. It is having the largest circumference, hence it will have the highest linear speed of rotation. And as we move from center towards the poles, the circumference of the circles are decreasing, right? With the pole having the least or negligible circumference, hence it will have negligible or 0 linear speed of rotation. Factually also we know that at equator the linear speed of rotation of Earth is 1670 km per hour and at poles it is 0 km per hour. And this difference in linear speed of rotation from equator towards the poles causes the effect called Coriolis effect. Now if we open the same 3D structure on a 2D platform, we will get something like this, in which this will be the equator, this will be the north pole and this will be the south pole. We know that the Earth rotates from west to east direction, and we have also seen that the linear speed of rotation at the equator is highest and it is minimum at the poles. For simplicity, let us assume that the linear speed of rotation at the equator is 100 meter per second and it is decreasing gradually as we are moving towards the poles, with it being 0 meter per second at the poles. So all the points at this place will have a linear speed of rotation equal to 100 meter per second, at this place 80 meter per second, 60, 40, 20 and eventually 0. Now let us assume that we have to throw a object towards the poles. This object will have a initial momentum eastward of 100 meter per second due to inertia, right? Now as this object moves in the air towards the poles, the surface beneath the object will be getting slower and slower. So what it would seem like is that the object is moving ahead of the surface beneath, and this apparent deflection is called Coriolis effect. इस चीज़ को हम इस तरीके से भी समझ सकते हैं. Let us say there are two persons, person A and person B. Person A is at equator with linear speed of rotation 100 meter per second. Person B is at a place where the linear speed of rotation is 40 meter per second. Now the person A wants to throw a ball to person B, and let's say that this happens in 1 second. So the ball reaches from person A to person B in 1 second. This ball will also have a eastward momentum of 100 meter per second because of inertia, right? So in 1 second the ball will move from person A to B, and also it will move 100 meters to east, right? Now due to inertia itself, the person A will also move 100 meters to east. So person A will come to this place, the ball will land at this place, right? But since the person B is at a point where the linear speed of rotation is 40 meter per second only, so the person B will move eastward by 40 meters only. And this 60 meters of difference of deflection of ball B is what is called as Coriolis effect. Now, if the object is at the poles and we have to throw the object towards the equator, in this case, the object will have a initial inertia of 0 meter per second. And as it moves towards the equator, the surface beneath the object will be getting faster and faster and faster. So what it would seem like is the object is lagging behind the surface beneath, and this deflection is called Coriolis effect. So in this case, the first case, the object is being deflected towards right of direction of motion, and in the second case also the object is being deflected towards the right of direction of motion. So in the northern hemisphere, we can see that the object are getting deflected towards the right of direction of motion. How is that happening? See, this is the direction of motion, this is the Coriolis effect, the net resultant force is this, so it is right to the direction of motion. Again, this is the direction of motion, this is the Coriolis effect, net resultant force is this, it is towards the right of the direction of motion. So in the northern hemisphere, the Coriolis effect deflects the moving objects towards the right of direction of motion. In case of southern hemisphere, when the object is being thrown from the equator towards the poles, the object will have a initial inertia or momentum towards the east of 100 meter per second. Now as it moves towards the poles, this surface beneath would be getting slower and slower. So what it would seem like is the object is moving ahead of the surface beneath, and this is the Coriolis effect. Similarly, if the object is being thrown from the poles towards the equator, initial momentum would be 0 meter per second and the surface beneath would be getting faster and faster. So this time what it would seem like is the object is lagging behind the surface beneath, and this would be the Coriolis effect. So in case of southern hemisphere, we can see that the deflection is towards the left of direction of motion, right? So in case of southern hemisphere, we can see that the direction of motion is this, Coriolis effect is this, and net resultant force is this. So deflection is towards the left of direction of motion. Similarly, direction of motion is this, Coriolis effect is this, and net resultant force is this. So deflection is towards left of direction of motion. To summarize, the concept of Coriolis effect was given by Gaspard Gustave de Coriolis in the 1830s. He was studying mechanical motions, during which he gave the concept. It is not a force, Coriolis effect is not a force but an effect of difference in linear speed of Earth's rotation, due to which all moving objects on Earth either deflect towards the right or towards the left, towards the right in the northern hemisphere and towards the left in the southern hemisphere. Let us now cover some of the common misconceptions related to Coriolis effect. Drain direction in sinks or toilets. It is a common myth that the clockwise or the anti-clockwise flow of water in the sinks is due to Coriolis effect. But the Coriolis effect is really insignificant on such a small scale. Drain direction is basically controlled by sink design, basin shape, and the initial water motion. Next, it affects all motions equally, but this is also not true. Coriolis effect is significant for large scale motions like global atmospheric winds, ocean currents, missile projectiles. but it is really insignificant for daily activities like driving, walking, etc. And we have already seen that it is not a real force. In the next video, what I will cover is why Coriolis effect is negligible or zero at the equator and highest at the poles, the impact of Coriolis effect on cyclone formation, and other applications of Coriolis effect. Thank you for watching the video.